Hello friends, you are watching channel number collage. The purpose of this channel is to take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will study centroid of composite sections. In engineering practice, we often come across composite sections or build-up sections such as a T section, L section, C section, I section, a dam section, or a gusset plate, etc., which are a suitable combination of simple sections such as a rectangle, triangle, a circle, a semicircle, or quarter of a circle, or some other simple sections. In the process of finding the centroid of a composite section, choice of position of x-axis and y-axis is important. For example, a T-section is symmetrical about. This is the T-section. The vertical y-axis drawn through the middle of the web. Y-axis drawn through the middle of the web. The centroid G lies on this y-axis, somewhere here. Its distance from y-axis will be, that is, x bar. Its distance from y-axis will be 0, that is, x bar will be 0. We will have to find only y bar, that is, the distance of centroid from the x-axis, which passes through either the top edge of the section or through the bottom edge of the section. If we choose the y-axis along the left edge like this, or along the right edge like this, the section will not be symmetrical about either of these axes. So we will have to find both x bar and y bar. X bar from left y-axis or x bar from right y-axis, and y bar from top x-axis or y bar from bottom x-axis. So choose the position of x-axis and y-axis such that calculations will be minimized. We draw x-axis along the top edge of the section. Here, we locate by simple methods the individual centroids G1 and G2 of the two rectangles on the y-axis. G1 and G2. Y1 is the distance of G1. Y2 is the distance of G2 from the x-axis. A1 is the area of the upper rectangle. A2 is the area of the lower rectangle. Moments of areas from x-axis equals A1y1 plus A2y2. Distance of centroid from x-axis y bar equals moment of area about x-axis divided by total area of the section, which will be A1y1 plus A2y2 divided by A1 plus A2. Since the section is symmetrical about vertical y-y axis, it becomes the centroidal axis, hence x bar will be 0. So, position of centroid G will be 0, y bar, which is here. Locate the centroid of a T-section shown in the figure. The dimensions of flange are 100 by 20 and that of web are 100 by 20. T-section is symmetrical about the vertical axis passing through the web. So this is the vertical axis passing through the web. So we have x bar equals 0. For finding y bar, split the T-section into two rectangles. For upper rectangle, A1 equals 100 multiplied by 20, that is 2000. 100 multiplied by 20. Y1 equals 100 plus 20 divided by 2, which is 110. 100 plus 20 divided by 2, which is 110. A2 equals 100 multiplied by 20, which is 2000. 100 multiplied by 20, which is 2000. Y2 equals 100 divided by 2, which is 50. 100 divided by 2, which is 50. Y bar equals A1 Y1 plus A2 Y2 divided by A1 plus A2. Substituting the values, we get Y bar equals 80 millimeter, which is this. We know that X bar equals 0. Therefore, the position of centroid G is 0, 80, which is here. G 0, 80. Find the centroid of the unequal angle 190 by 160 by 10 millimeters. So this is the unequal angle with dimensions 190, 160 and 10 mm. Unequal angle is not symmetrical about x-axis or y-axis. So we have to find both x bar and y bar. A1 equals 160 multiplied by 10, which is 1600. So A1 is 1600. A2 equals 190 by 10, which is 1900. A2 is 1900. X1 is 160 divided by 2, which is 80. X1 is 80 mm. X2 is 10 divided by 2, which is 5. So X2 is 5. Y1 is 190 plus 10 divided by 2, which is 195. Y2 is 190 divided by 2, which is 95. So Y2 is 95. Values of A1, A2, X1, X2, Y1 and Y2 are provided here. We have X bar equals A1 X1 plus A2 X2 divided by A1 plus A2. Substituting the values, we get X bar equals 39.28 millimeters. So this is X bar 39.28 millimeters. Y bar is A1 Y1 plus A2 Y2 divided by A1 plus A2. Substituting the values, we get Y bar equals 140.71 millimeters. So this is Y bar 140.71 millimeters. So So we get the position of centroid G here, which is 39.28, 140.71. Locate the centroid of the eye section shown in the figure. The dimensions of the eye section are: top flange 110 by 22, web 100 by 22, lower flange 140 by 28. Eye section is symmetrical about y-axis passing through the web. This is the web. So its centroid lies on the vertical y-y axis. So this is the vertical y-y axis, which implies that x bar will be 0. For finding y bar, split the eye section into 3 rectangles: 1, 2 and 3. A1 equals 22 multiplied by 110, which is 2420 mm square. 22 multiplied by 110. A2 equals 100 multiplied by 22, which is 2200 mm square. So A2 is 2200 mm square. A3 is 140 multiplied by 28, which is 3920 mm square. Area of the bottom rectangle. Y1 equals 28 plus 100 plus 22 divided by 2. 28 plus 100 plus 22 divided by 2, which is 139 mm. So this is 139 mm. Y2 is 28 plus 100 divided by 2. 28 plus 100 divided by 2, which is 78 mm. So Y2 is 78 mm. Y3 equals 28 divided by 2. 28 divided by 2, which is 14 mm. So Y3 is 14 mm. The values of A1, A2, A3, Y1, Y2, Y3 have been provided here. We have y bar equals A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. After substituting the values and evaluating, we get y bar equals 55.66 millimeters, which we show here. We already know that since the section is symmetrical about vertical y-y axis, x bar equals 0. So we get G as 0, 55.66, which is the position of the centroid G here. Locate the centroid of the C section shown in the figure. This is a symmetrical C section where the top and bottom flanges have similar dimensions: 100 by 20 top flange, 100 by 20 bottom flange. So this C section is symmetrical about the x axis passing through the web. So its centroid lies on the horizontal x axis, which implies y bar equals 0. For finding x bar, we will draw a vertical y-y axis passing through the left edge of the C section. A1 is 20 multiplied by 100, which is 2000 mm square. A1 is 2000 mm square. A2 is 60 multiplied by 20. 60 multiplied by 20, which is 1200 mm square. 1200 mm square. A3 is 20 multiplied by 100. 20 multiplied by 100, which is 2000 mm square. A3 is 2000 mm square. X1 equals 100 divided by 2. 100 divided by 2, which is X1. X2 is 20 divided by 2. 20 divided by 2, which is 10 mm. X3 is 100 divided by 2. 100 divided by 2, which is 50 mm. The values of A1, A2, A3, X1, X2, X3 have been provided here. We have X bar equals A1 X1 plus A2 X2 plus A3 X3 divided by A1 plus A2 plus A3. Substituting the values and evaluating, we get X bar equals 40.77 millimeters, which we show here. We already know Y bar equals 0, so G will be 40.77, 0. The centroid is located here at 40.77, 0. So this is about finding centroid of some simple composite sections. In the next video, we will find centroids of some other composite sections. If you like this video, please subscribe this channel. Share this video with your friends and relatives. Thanks for watching. Have a nice day. Keep watching Number Collage.